Available now? Look
Yes,
at that.
I am.
Well,
Hi, everyone.
good morning, yes. We're very glad to have you here virtually. Well, it's 8 o'clock in the morning at your place, so thanks a lot. As you see, we have quite a few people that are eager to hear what you're going to talk about. So I'll just hand it over to you, and the people who have questions afterwards, you just let them know. And I have a microphone, so please come to me and take the microphone and ask the question. Okay, Emily, it's all yours.
All right, excellent. So thank you very much for letting me participate virtually. I have two small kids, and it's hard for me to get to Europe, and I've been very sad about not being able to travel to Europe very much for the last few years. So this is really outstanding, and the setup looks great. My name is Emily Lakdawalla. I am the blogger, senior editor for the Planetary Society, and I blog every day at planetary.org/blog. My main beat is robotic space exploration, robotic exploration of our solar system. So I follow what's going on with all of the roughly 20 robots that are exploring the solar system, both from NASA and from ESA, JAXA, and other places. I guess India is talking about launching a Mars mission pretty soon, which is very exciting. So today I thought I'd talk briefly about one of the most exciting missions right now, which is of course Curiosity, but mostly I would really like to answer your questions. So I'll do a brief spiel, and then please think about what you would like to ask about Curiosity or really any other space exploration that's going on right now. So I'm going to share an image that is one of my favorite photos of Curiosity, both because it's cool and because I took it. It's this one. So this is the face of Curiosity, and I have to say that I was and remain an enormous fan of the Spirit and Opportunity rovers, and so I was not really, I didn't like Curiosity at first. It seemed so big and ugly and clunky, and it replaced these two robots that I loved so much, but when I had a chance to look Curiosity in the eyes, all of a sudden I definitely loved this robot as well. And the reason that I show the face of Curiosity is because I want to point out the locations of all of the cameras that you can use to view Mars. And in fact, you can see all of these images on the internet almost as soon as they're returned to Earth. So first of all, we have the largest eye is up here. This one is called ChemCam. And it's actually it's a telescope that it's attached to an instrument called a laser-induced breakdown spectrometer, or LIBS. And what this thing does is it shoots a laser at distant rocks, and it ionizes some of the material right at the surface into a plasma. It's so hot that it's emitting radiation. It's emitting light in ultraviolet spectrum, and so this thing has a spectrometer that breaks down that light and can use it to determine the elemental composition of the rock that it blasts with its laser. And the reason that this is so useful is because they can actually sort of do a spot check of the composition of a rock from a distance. They can assess the chemical composition of a rock from quite a long way away and make a very informed choice about which rock to approach very closely. And in fact, they're doing that right now. They're doing their very first contact science on a rock on Mars, using a rock that they selected from a distance with ChemCam. The next most obvious eyes are these two. These are called MastCam. The instrument is MastCam. There are two MastCams. There is a wider angle one, that's the left eye, that's called MastCam 34 because it's a 34 millimeter camera, 34 millimeter focal length. And then there's a narrower angle MastCam 100, and that's the smaller eye on the right. So the two eyes, originally the system was supposed to have a zoom capability, and both eyes would be able to zoom all the way out and all the way in. But that was actually de-scoped from the mission in a weird cost-cutting measure that NASA tried to do at one point. It didn't save them very much money, and it left Curiosity with the ability to have one eye focused out, one eye focused in, and it makes distant color 3D imaging a little bit difficult, but it's still, those cameras are still wonderful and the images are still great to look at. Finally, up here on the mast, there are two pairs of nav cams. These are what they sound like. They're used for navigation. Curiosity takes a panorama of about 12 navcam images spaced around a circle to get a quick 360-degree look at her surroundings. There are two pairs because they have one completely redundant set of cameras as well as electronics for the rover, because this rover is supposed to last for 2 years. And so if if one computer system fails, they have a complete redundant backup to go to. So right now, I actually don't know which pair they're using, whether they're using the top pair or the bottom pair. I'm guessing it's the top pair. Those two nav cams, it's kind of interesting. They're identical to the ones that were on Spirit and Opportunity. But there is one notable difference, and that's that in Spirit and Opportunity, the nav cams were situated in between the two science cameras. So their stereo separation was very similar to the stereo separation of your eyes or my eyes. But on this rover, they're separated by 14 centimeters. So the rover has a much wider, it's kind of like a hammerhead shark almost. You have a much wider stereo field of view, and it produces a lot more parallax in images. So it's taken a lot of getting used to understand how far away and how large objects are when we see them with this rover's nav cams. So those are all the cameras that are on the mast. There are a couple more cameras. There are some belly-mounted has-cams. There's a camera on the end of the robotic arm. And as I mentioned earlier, you can get to all of the images that these cameras take on the internet almost as soon as they're returned to Earth. And there's 3 different ways that you can do that. The first one is the official website, and that's here at JPL. And by the way, I have just tweeted links to all 3 of the sites that I'm going to be showing you, so you can check Twitter to see that. And now I'm enjoying seeing you all check your phones. So this one is the official website, and it splits down the images into the different cameras where you can find the recent images from Mars. But there are actually 2 enthusiasts who produce their own ways of getting at the raw images stored on JPL servers. Here's one. This one was made by a guy named Ludo Stellingwerf, I think. No, this is Joe Knapp's. So this is one website made by a guy named Joe Knapp. And what's wonderful about this website is that it organizes all the images so you can see the ones that are released most recently. And what we're looking at here are some images that were taken. They just came out, they were just released like minutes ago. And they came back from Mars. These are from the MALI, the hand lens imager, and they're of a rock that they're actually doing contact science on right now. It's the very first rock they've tried to investigate with their instruments. Now, when I clicked on this image, you'll see that it came up as a very small image in the center of the screen. That's because Curiosity returns to Earth thumbnail versions of all of its images first, and they assess the quality. They choose which ones to return at full resolution. They don't return all images at full resolution because they have bandwidth limitations. And so as I'm scrolling very quickly through these, I'm looking for an image that is at higher resolution that I can show you. And here I can see that this one is 1648 by 1200. So here is a high resolution image fresh from Mars of this very first rock that they're investigating with the hand lens imager. And you can see little bits of dust piled up in the wind eroded pits in this rock. This is really cool, actually. I haven't even looked at this image yet. It's pretty awesome. And then you can scroll down and you can see the NavCam view. This is from one of those mast-mounted NavCams of Curiosity's robotic arm placed upon the rock that it's investigating. So this is from a mast-mounted camera checking out where MALI has placed the camera on the surface of the rock. And so I find these raw images pages a wonderful way to follow the drama, follow the daily activities of the mission. They upload images every few hours, so it rewards your attention to come back to these websites over and over again. Here's a cool image showing you a donut that the rover had turned in the landscape. You can see its tracks, which is pretty neat. There's one other website. This one's produced by a guy named Ludo Stellingwerf, and his is somewhat similar to Joe Knapp's, except it has another really cool feature where you can select certain images and it will output a text listing. So you can run it through a script that will download all the images that you want. So anyway, that's a quick tour of the kinds of places that you can go to get the raw images from the mission and follow all of the drama of what's going on every day. And I think that it's one of the most wonderful things that NASA has been doing with its missions recently. The European Space Agency has not yet done this with one of their science cameras, although they had a camera on Mars Express that they termed the Mars Webcam. It was called the Visual Monitoring Camera, and it was just a very simple little camera that was put on Mars Express only to watch Beagle depart. And it wasn't used for several years after the departure of Beagle, but then they decided, well, we have this camera, we might as well turn it on, see what it takes pictures of. And it produces really cool pictures of a global view of Mars, which no other camera in Mars orbit can get for you right now. Now, unfortunately, since Mars Express's memory problem last year, they haven't been able to turn the webcam back on as far as I know. But I'm hopeful that they'll be able to get that instrument back on, which is a really neat way to check in on the Mars Express mission and see what's going on with an active Mars mission. So I guess that's all the little spiel I wanted to give right now. I'd be delighted to hear your questions and answer them about Curiosity or any other robotic exploration mission that's going on right now.
Okay, thank you, Emily. People in the room, questions, please. Yes, hang on.
Hi, I'm Markus Landgraf from ESA. There's a community inside the science community that says robotic exploration is too risky and too expensive. You rather should go with remote sensing. What is your reply to that argument? I'm not part of that.
You mean landed missions? Is that what you're referring to?
Yes, robotics on the surface versus remote sensing.
Well, the two, of course, go hand in hand. Your remote sensing will always give you a more complete look at a planet than you can get from a landed mission. A landed mission, after all, can only investigate one very small spot on the surface of the planet. But the ground truth that you get is extremely important for just such a very simple thing as Huygens. You know, the Huygens probe, what it taught us about the atmosphere of Titan. There are a great deal of surprises in that mission, particularly in the wind speeds. As it descended toward the surface. And wind speed is one piece of data that is an extremely important contributor to the whole climate model for the entire planet and leads to our understanding of how Titan's atmosphere, how all of Titan's systems work. And even if Huygens had done nothing else but broadcast its radio as it descended to the surface so that we could track it and see what it was doing as the winds were blowing it around, it would have produced revolutionary understanding of how Titan works. So I think there is definitely an important place for probes of all sizes, for both small ones, little atmospheric probes like the one that was sent into Jupiter by Galileo, all the way up to large ones like Curiosity. Curiosity is the most sophisticated thing that's ever been sent to the surface of another planet, and I have to tell you that I am extremely relieved that it actually worked, because I'm not sure what would have happened to NASA if it had not landed safely. It's certainly very risky, but I think it's something that we have to do.
Good for fitness as well.
Hi, Emily, it's Daniel Skuka here. I'm just wondering if, and I'm happy to see that your home office bookshelf in the background is no neater than mine. This really makes me feel happy. I'm just wondering, could you give an estimate or a kind of a feeling as to how valuable it is to NASA for outreach and PR, the fact that they are delivering these, basically science-grade images directly to the web in more or less real time? What's the value of that?
Well, it's funny that you ask that, because the people who are pushing the release of the images understand how valuable it is, but it's still not a sales pitch that everyone in NASA has accepted. And so I actually went to NASA headquarters this summer to deliver a talk to explain to people that by releasing raw images and allowing the public easier access to the science data, they are getting a huge amount of bang for their buck. They're getting a great deal of outreach being performed by members of the public who are posting all of this stuff on social media, on their blogs, who are sharing it with other people in all different kinds of ways. But more than that, the people who are accessing these raw images and are processing them and are making mosaics and color panoramas and comparing one image to another as the rover is driving along the landscape, remembering what old rocks looked like and comparing new ones to the ones that it had seen a long time ago, they're actually producing value that the scientists on the mission team find useful. I've heard Steve Squires, who's the head of the Mars Exploration Rover mission, talk about how he visits a forum that I'm an administrator on called unmannedspaceflight.com. Before he often goes to the JPL website, because he knows that when he wakes up in the morning, the Europeans will have already looked at the images that came down from the rovers, assembled them into beautiful seamless panoramas, and all he has to do is go to the forum and click to open up the image. He doesn't have to dial into his VPN. He doesn't have to bring up one image at a time and put them together himself. Everybody who's on unmanned spaceflight has already done it. And so he actually finds operational usefulness in what the amateurs and people in the public are doing. The other argument that I make is that when missions release press released images with captions, those press released images are produced by scientists, and they're produced for science purposes. So they often emphasize subtle details, they stretch the contrast, they're trying to make it easier to see what's in the data. But that actually misrepresents how you would see it if you were looking at it with your own eyes. And a lot of the public actually does not understand when space agencies release false color or stretched or enhanced color versions of images. They don't understand, first of all, that they're enhanced, and second of all, they don't understand why NASA would want to do that. They think that, that some people, of course, go straight to the conspiracy theory and think that NASA is trying to hide something. So the members of the public who take these images and ask the question, what would it look like if I were sitting there, and produce pictures that are the colors, the subtle shades as humans would see them, they're really doing a great service, I think, to the space exploration community. And I think that space agencies should take better advantage of the way that amateurs produce these beautiful illustrations for use as illustration, not for science, because the scientists know best how to get the science out of their instruments, but for illustration purposes, to show what it's like, what it would be like if you were actually standing there flying with these robotic spacecraft exploring the solar system.
Okay.
Hi, Emily. This is Martin. Maybe it's out of the topic about curiosity, but I wanted to ask something about the New Horizons mission. Like, what do you expect out of this? Like, regarding the capacity of the photos, I know that it will pass Pluto just shortly, and then they will reach the Earth. And like, what's the prediction about how it will change our understanding about the outer solar system and the Kuiper belt objects?
Well, you know, it's funny, whenever you visit a new kind of object with a new spacecraft, everything that you thought you knew about the solar system suddenly changes. And sometimes it gives me a little crisis of confidence in science, because every time we learn something new, it seems to make everything that we had already thought that we knew wrong. And I think that the New Horizons is guaranteed to show us something surprising about what's going on at Pluto. We know that there are exciting things happening at Pluto. We know that there are changes that we have seen with telescopes on Earth in the color patterns on its surface. So there must be something happening on its surface. Most likely it's frosts are forming in one place and evaporating from another. But you know, that explanation may not be correct, and what that means in terms of what the surface actually looks like when you see it up close is anybody's guess. I think all you have to do is look at Triton, which is one of Neptune's moons, the largest moon of Neptune, visited by Voyager 2 in 1989, and see how different Triton is from all of the rest of the outer solar system icy planets, icy moons, to realize how different Pluto is going to be. And not just Pluto, but also Charon. Charon is a very large body itself. It's half the size of Pluto, and it's larger. Charon is actually larger than most of the other objects out there beyond Neptune. So we're actually getting two different worlds that we're going to get global maps of that I'm sure are going to be quite different to anything that we've seen before. And I'm very excited. I'm extremely excited to see what Pluto is going to look like up close. I have been researching some of the other objects out there in the Kuiper belt recently, and I'm kind of sad actually that we can't visit any of these other things because they're so diverse. The objects out there, we know from telescopes that they have different colors, different compositions, and that their range is broader than what we see in the icy moons in the outer solar system. So there's a lot of exciting things to see out there, and I hope that New Horizons is not the last mission to one of these bodies that we see in my lifetime.
Hi, Emily. It's Nick, astronomer. Do you think now other space agencies have something to learn from using people like Adam Steltzner, who is just a rock star, to promote MSL, and you know his background and what he went through, and you know the grief he had trying to convince him to go with the Sky Crane? Do you think those kind of risks and that kind of personality is what really promoted MSL so much, and could other agencies learn from that?
Well, I suppose they can, although I have to say that, Adam's been around for a long time. He was doing these kinds of the presentations and being put in front of the public for Spirit and Opportunity, just like he was for Curiosity. And so I think that there's been a real shift in the ability to get these kinds of stories out into the public, so that more members of the public are driving media these days, and it was public interest finally being able to be expressed through Twitter and Facebook and other social media that actually brought Adam out into the public more so that more people could see him. His story had been told 9 years ago. I saw him giving very similar talks to large crowds of kids and things on Spirit and Opportunity that for whatever reason the stories didn't get traction then, but they're getting it now. And sure, other space agencies have something to learn, except that it's always hard to predict how to make something go viral. And who would have guessed that Mohawk guy would have been what would bring the control room out in front of the entire world? And he's just a guy. he's an engineer. He's one of many talented, bright, young engineers, creative people at JPL, and it just so happened that that one thing clicked and went viral. It wasn't pre-planned by NASA, it just happened. And I guess the thing that NASA did do was that they rolled with it. They didn't say, oh no, you shouldn't talk to Bobak, you should talk to this other more senior person. The public asked for Bobak, and they got him, and they got Adam Stelzner, and because NASA gave the public what they asked for, I guess, it got more traction. So perhaps that's a lesson that ESA could learn.
Hi, Emily. This is Ingo. First of all, thank you for this hangout. It's really great to have you. And my question is, what's your opinion of the selection of the InSight mission recently over the Time mission, for instance? What is your opinion on that? Do you think it's the right choice? And also, maybe you know something about the drivers behind this decision. I would be really interested in that. Thank you.
Well, I don't know a whole lot. I will admit that I would have loved to see, actually, all three of the Discovery proposals were really exciting. I have long hoped that we would get a seismological station on the surface of something other than the moon. And after all, the ones that we had on the moon were left there in Apollo days. And so it's extremely exciting from a geophysicist point of view to finally have a seismological station heading to the surface of another planet. That being said, I would have loved to see a boat floating on Titan's oceans. And I would have loved to see NASA send something to the surface of a comet. This was a really difficult choice. I had actually hoped that NASA would select two, because they're talking about sending one small Mars mission in the 2018 Opportunity now that they insulted all of you guys and dropped their participation in ExoMars. And I hope that they would pick InSight at least for that opportunity and then pick one of the other Discovery proposals. But I think that was wishful thinking. The budget situation simply doesn't permit that. As for what drove the decision, I think that it's pretty clear when they pick a mission like InSight over the Titan Mari Explorer or the Comet Hopper that it was simply the safer bet, which is a little bit sad because that's not really what Discovery is for. Discovery is for trying out new technologies. But I'm not privy to the decision that was made. I don't really know about the technological readiness of the kinds of technologies that needed to be used to make either the Titan Mari Explorer or Chopper work. So I don't have any particular insight into that. I'm very happy that InSight was selected and very sad that we're not seeing either Time or Chopper.
Okay, we have room for one more question. Daniel? No one else? Okay. Make the fat guy run.
Hi, Daniel again. Last question from me. What are your plans for covering in your in just sort of the same way you always cover missions for Rosetta when Rosetta arrives at the comet in 2014?
I will certainly be doing a play-by-play of Rosetta's arrival, and I think actually ESA has an opportunity in Rosetta because of the personality of the principal investigator on Dawn. I kind of felt cheated by Dawn's approach to Vesta because they released very few images, and the ones that they released were released in a very dilatory manner weeks after they were acquired. And that was so frustrating because Vesta was a new world that and a new kind of world that we had never seen before. And they could have brought the public along through rapid release of raw images on this, the first sighting of land and the opening up of the landscape as we got closer and closer. But we didn't get to do that on Dawn. And I think that Rosetta really has an opportunity here to show up that other small body mission and carry the public along by, they don't even have to release all images, just quick release of images as we see the comet grow in the field of view would be just such an exciting thing, because I know how wonderful Rosetta's cameras are. I've processed some of the images from their Mars flyby, and the camera has an enormous detector. It has 4 times the area of most other space cameras, other framing cameras ever sent on these kinds of flyby missions. So I really can't wait to see the images that Rosetta's going to be returning. And then we have the excitement of Philae, and I can't wait to see that thing land on the surface as well. So it's going to be a truly exciting mission, but it is up to ESA and of course to the principal investigator on the OSIRIS camera to release images, enough images quickly enough to bring the public along and allow us to participate in that exciting approach to a new world.
Okay, thank you very much, Emily. I think everyone would like to keep on talking, keep on asking questions, but we're running out of time. I'd say I speak for everyone that we're very glad to have you virtually in our SpaceUp Europe, and we hope that we can see each other in the near future.
Yeah, thank you very much for having me, and I think the kids are starting to let me out of the house once in a while, so hopefully I'll be able to make it back to Europe for another meeting soon.
Okay, cool. Thank you very much.
Bye-bye.
Bye.
Thank you.
Okay, people, we have another hangout scheduled. Okay, so who's doing that? Aiko?
Yeah, as soon as